Hello and welcome to the MecSoft demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mecsoft.com. In this demonstration, RhinoCAM 2017 is used to perform 4-axis radial machining on parts with ornamental and filigree design. You will see profiling, index roughing, parallel finishing, and machine tool simulation, all in 4-axis. Without further delay, we invite you to sit back and enjoy the demonstration.
I did receive the 2 files, and also I received the machine tool that you guys are working with. So I'm going to go ahead and first bring in the part in here. So I'm going to just drag it into Rhino and then pick open. So first we'll take a look at the part number 1 that you sent us.
Great.
Okay. So both the parts what you have requires to be machined on a rotary check, or what we call it as a 4-axis machining process. Now, if I take a look at the picture of the machine tool that you've sent us here, so your rotational axis is either, it should be, in this case, based on what I'm seeing, it could be either X or it could be Y, but most likely it looks like this is your X-axis. Correct me if I'm wrong.
Yeah,
Okay.
that's correct.
So, okay, perfect. So we would be defining the machine tool in here as 4-axis in RhinoCAM, and then we'll be going through the process of establishing the 0 and then programming the toolpad. So the first step is, as you load the part in Rhino, you will notice that if RhinoCAM plugin is installed and you have the mill browser selected, the machining interface appears over here on the left panel. And RhinoCAM supports both inch and millimeter units for programming. So it could be working in millimeters or it could be working in inches. So whatever units that you use for designing the part, if you have it in millimeters or inches, we automatically set the parameters for the CAM to those relevant units.
Oh, okay.
So you go into the machining browser in here, and there's 2 main tabs. You have Program and then the Simulate tab. So under the Program tab, there's a ribbon interface, as you can see, and there's 3 different groups: machine setup, stock, and machining operations. So the workflow is going from left to right as you work your way through this. Now the first step is defining the machining process. So you click on machine setup, and then we pick the definition type. Here I'm going to do manual, and then I'm going to choose the number of axes to be 4. So as I pick the number of axes, it gives me an option to pick the configuration. It's going to be a rotary table. So we want to set it to table, and then the rotational axis, we're going to pick X as the rotary axis, and then click OK. Now the next step is you identify your machine tool, the controller, the post processor that you'll be needing. And we have posts for over 200 plus different machine controllers, so it covers a wide range of machine tools that are out there. So if you're working with Mach 3 or whatever your controller is, you pick that from the list, and we can output either in inches or millimeters, whatever your preferences are.
I have a question. Do you all have Meltronic controls on there?
We do. We have a post for Meltronics in here, as you notice it down the list here. Meltronics.
You got an NV20 gun?
Yeah, I have a Centurion 6.
Okay, we got one right here. So we click on Centurion 6, and we also have a built-in post generator. This would allow us to make edits to the post processor. This is how we develop new post processor, configure existing posts, make any modifications or edits to the post processor as well.
Okay, great. Thank you.
And as you notice here, this Meltronic Centurion 6 is set to output in inches. If we need to switch it to millimeters, we can switch it to millimeters as well.
Okay, cool.
So I
Thank
set
you.
the post processor. You're welcome. And then it's set to .nc. If your Meltronics prefers a different extension, you can change the extension type in here, and then you pick OK. Now the next step is to build your stock material in here, which is going to be your workpiece, the blank. Now, in this particular case, looks like you may be using like a tube. Is that right? Your workpiece?
Yeah, it's
Okay.
can't remember right now. I was looking at the other one for so long, but I forgot which size that one is. I think it's a 58 thousandths wall. Hold on.
So what we can do here is in Rhino, we can actually go into curves and then do what is called a duplicate face border. Curve from objects, duplicate face border. And I can just face right in here, and it extracts those two circles. And if I analyze the diameter, it'll tell me what the size of this is. So this one is 27.4 millimeters, and I can do the same thing for the one right over here. That's 30.4. So if the part that you're going to be working, starting out the stock blank or your workpiece is going to be just an extrusion in here, I could create a solid extrusion in here, solid extrude planar curve straight, and I can go right up to this edge, and that actually creates a solid tube, as you notice it right there.
Oh, cool. Yeah.
Now, we can define stock as a cylinder or as a box with the expert configuration of our product. In our Pro, we also have the option to do a stock by selection, where you can actually highlight or select this geometry that you built in, which is the solid geometry, which is the tube, and then I can do a stock from selection. So this feature of defining the stock as a tube is available to you in the Pro configuration of RhinoCAM. Now with the Expert configuration, you will be able to define a stock as a cylinder stock, but not as a tube with the inside ID being hollowed out. Am I making sense?
Yeah, yeah.
Okay, so if you're considering...
Not having it as a tube isn't really strictly necessary.
Well, it's more for your visualization purposes in simulation, you know, based on this particular part. So I just wanted to show you both the options, so that way you know you're aware of the differences between the two configurations. You know what you would be getting in the Pro versus what's offered to you in Expert.
Okay, great. Yeah, that sounds good.
We do have a feature list in the product. So if you go to the help, and if you go down to configurations, this will actually list all the features. If you look at the stock from selection, you see it shows in Pro configuration. However, the the cylinder stock and all the other stock types are offered in Expert configurations.
Okay.
Okay. Now, let's go ahead and stick with the cylinder stock in here. So once you define the stock, the next step is to establish the origin. So typically, when you zero it out, do you zero it out to the center in the Z, and do you zero out to the top? The Z, do you put it in the center and XY to the center, or do you zero it to the top right over here?
Well, we would do X on the end and Y on the top.
Okay.
Y in the center of the top.
Okay, and how about the Z?
The Z will be the top surface of the tube.
Okay. Would you prefer the left or the right end of it?
Well, the right end would be the X0.
Okay. So perfect. So what we would do here is go to Align, click on Set World Coordinates. We pick Set to Stock. I would say higher Z, East. So that'll set your XYZ0 right up to the top. And then we pick OK. It's actually going to do a transformation of your part and the stock, as you notice it. And if I display the coordinate system, you'll see that it's set right up to the top.
Nice. So if that part was just randomly somewhere else in the middle of the plane, when we open the file, once we set that 0, it'll just put it where it needs to be, right?
Yep, you can even model it the way your 0 needs to be, so this will also eliminate the one extra step that you have to do to establish the 0, or if you can do it in the CAM as well.
Okay, great.
Okay, so now the next step I'm going to do here is make sure my center of rotation is set to the center of this blank in here. So I go back into my machine setup, and for the rotary center, I'm going to say pick, and I'm going to use the center snap in here. And I can just go right to the center of this tube, and that's where my center of rotation is going to be.
Okay.
So I can zero out the X and the Y values, and just leave the Z at, which is minus 15.23, right? You can, or you can even insert a point in here in Rhino. You can say you want to insert a point, and that could be right at the center, and you can use the point snap to go pick that point as your center as well. So go back into your machine setup and select the point snap and just go pick that point, and that establishes your XYZ0 right there.
Okay.
And if you need to modify or re-enter the parameters, you can just go back and type it in and then pick OK. So there's your XYZ0. Any questions so far?
No.
Okay. So I'm going to just hide this tube that we had created in here. Now typically, for cutting out these shapes, you could cut them out as profiles. The piece inside could fall apart, or if you want to hog everything out, you could do like a pocket.
Okay.
So if you just wanted to follow the contour of this, we would do a profile. And we have methods for 4-axis profiling, 4-axis pocketing, and facing, and these can be used on parts that have constant radiuses, like the one that you have right here. It's a constant radius. So you can go into 4-axis methods, and you'll notice that these are the different 4-axis continuous methods that you could program. And we have 4-axis facing, pocketing, profiling. Now these can be used for like wrap features, where these features are wrapped to a part or cylinder that has a constant radius. And in this case, this is a good example for that. Now, rather than having to go through and pick each of these edges to define the boundary, you can use the feature in Rhino called what is called the curve from objects duplicate border. You can do the duplicate face border. Just pick the face right there, and it actually creates the curve boundaries around each of these faces as you notice it.
Yeah.
That makes your selection process a lot easier. So you go into 4-axis, you pick profiling, and it warns me here saying that my rotation center and the Z0 are 2 different locations. I'm just going to accept that because certain machines expect that your Z0 and the rotation center right to be in the center of the part. So some machines do not handle the offsets, but most machines do handle it. So we just put out a notification, like a message for the user so they are aware of it. Now you pick the curves. So here I can just go pick these as my geometries for cutting it. So I could be selecting either the curves, or I can go individually select each of those surface edges from it. So I'm just going to go pick each of these in here. And I'm going to pick this one too right here. So I have all of these selected. As you notice these boundaries here, I go grab a tool for it. Now I had a library of tools loaded, but I could go in and add new tools as I create new operations. So I would be using like an end mill. Now since this part is fairly small, what size cutter end mill would you like to use for it?
Let's use an 1/8 inch.
An 1/8 inch. Okay, you want to go something smaller than an 1/8 inch, or you want to stick with an 1/8 inch?
1/8 will be fine.
1/8 would be fine. Okay, so that would be 3.175 millimeters. And I can also set my flute length, the shoulder length, and the tool length in here. I can also update my properties for the tool. The tool numbers can be set right in here, so I have it set to 4, but I can change them to tool number 1, specify the material for the tool, set the feet and speeds. This can be set based on the material you're working with. We also have a built-in feet and speeds calculator, depending on the stock material and the tool material. So if you're working with steel or titanium or whatever material is, you could pick the
Okay, this would be 4130 steel.
Okay, 4130, and you have
And we
your...
want to get a carbide end mill.
Okay, it's going to be a carbide, okay. And you can set your surface speed, the feet per tooth, and it can give you recommendations on your cut feet and speed. So if I change this parameter in here, the feet per tooth, you'll notice that it automatically recomputes the spindle RPM and the feed rates. And I can change my spindle RPM, and you'll notice that the cut feed rate automatically gets updated. I can accept this, save, edit to tool, and now my tool is defined. So we have the flat mill 1/8 inch. You go to feet and speeds, you'll notice that the feet and speeds are being loaded from the tool. We can establish the clearance definition. Here we could set it to stock max plus a radius, so you'll notice that the clearance is being set to a 6 millimeter above the maximum radius of the stock. And we can establish the cutting parameters in here. So I'm going to set the tolerance. I could choose my cut direction. I can specify whether to cut inside or outside. In this particular case, we would like to cut on the inside of these the curves. Set the cut levels in here. So this would be basically the thickness in here, the height, how deep you want to go. So you can actually use the tools in Rhino to measure it if you'd like. You could analyze a distance. Then I can pick the 2 points in here. So that's about a 1.5 millimeters. So maybe I can go slightly deeper into it. Maybe I could say 1.6. Then I could split it up into multiple steps. I could say I want to go in steps of 0.2 millimeters. And if you'd like to do any entry and exit, you could do that, or you could just set it to none, and pick generate. So this is going to produce a profile cut.
Cool.
And if the cutter is too big, can't fit into it, it's not going to gouge the part.
Right. Well, we're going to have a radius in each corner anyway, so
Okay.
it's just not on the drawing that way.
Okay. So what I programmed here was a profile cut, as you noticed it. So it just
Right.
follows the contour around it. So now we want to run a verification in here. We got the operation selected, and then I'm going to hit the play button. And this shows your profile cut. Now you're noticing that in this particular case, what you're seeing is the tool following the cut pattern, and the part remains stationary, because what we're doing here is just a simulation of the cut material. We're not doing a machine tool simulation in here, so as you notice it right there. And the tool remains normal to the axis of rotation.
Right.
Do you have any questions so far?
Oh, no.
Okay, so I'm going to let the simulation run to end. You can see the progress of the simulation in here as well. Once this has been simulated, I can repeat the same process for the feature on the other side as well. I can switch back in here. And now when I do a save, or if I do a save as, this information automatically gets saved to the Rhino 3DM file. So it's not adding any additional file formats. I'm going to make a copy of this operation, right-click, copy and paste. And now in this particular case, I'm going to double-click to modify it. And all I'm picking is this boundary right in here. And I pick generate. So in this particular case, I'm going to process the tool path for the
Awesome.
on the bottom half. And the system will figure out all the angles to compute for the rotations.
Somewhere along the line, you have something that shows it, how it would actually be on the machine with
Yes,
the parts running.
we do have a machine tool simulation available, and we do have a handful of machine tool models that are included in here. We can add new machine tools as well, so we can help you put that in place for the machine tool simulation.
Is that included in the expert version?
Yeah, the machine tool simulation comes with the expert and the pro configurations.
Okay, great.
And I will be able to demonstrate the machine tool simulation. Now, in order for the machine tool simulation, I need to put the rotation center over here on the back of the check here, and then I would probably have to set the work 0 to the top. So that's that's the way I would have to establish that for the machine tool simulation in order to demonstrate that. And I'll show that to you in just a moment.
Okay.
Okay.
All right. So, any questions on the toolpath processing in here?
No. Seems
Okay,
pretty
you can also
straightforward.
go right-click and do an information to get the estimate on the machining time. This will depend on based on the parameters that we put in, so it computes an estimated time for you.
A lot faster than it does to cut it by hand.
Yeah.
I agree.
Yeah.
Now we do a post process, right mouse button click and then select post, and now the two operations that we programmed are being posted out.
Mhm.
And it'll automatically process the code, and the output file will show up in a text editor, like you can have it set to output in like a notepad, which is the default. And as you see here, it shows your A-axis motions as it rotates, your X, Z, and A.
Mm-hmm.
Cool.
And this can be now transferred out to your machine tool. So let's
Okay.
look at a machine tool simulation. So I'm going to save this out. I'm also going to save a copy of this part. I'm going to save this as part 1A. So we'll run the machine tool simulation. So to do the machine tool simulation, I would actually have to put the 0 over here to the center, because the check is over here on the side. So I would have to 0 it out. So I'm going to go back in here to do align set world, and I'm going to pick set to stock box mid Z west. Okay.
Yep.
And I could set my work zero up to the top in here. I can insert a work zero to do that. I'm going to go back into my machine tool definition to zero out these parameters in here. And I can pick load from file, and we have a variety of different machine tools. So for example, I could choose something that would be similar to what you have. Could be like a machine tool that has, very similar to what you have right there, right?
Okay.
I'm going to regenerate these tool paths. And I'll go ahead and run a simulation with the machine tools. I toggle the machine tool visibility on, select an operation in here. You have the stock model displayed. I'll hit the play button, and there's your machine tool simulation.
Awesome.
Okay, this is what it would actually look like when you're cutting in real life.
Pretty cool.
Absolutely.
Yeah, that's turning.
Nice.
So you can see the A-axis turning, and there's your linear motion in the X, and then the Z.
Right.
That's awesome.
So, so we can add your machine tool model into it, or we can take one of these existing models in here, and we could, update it for you guys. So we could call it Miltronic Centurion 6. So we may need some, like STL files that represents the machine tool, so that gives you information for it. So here, as you can see.
Well, right now, I'm using the Mach 3.
Yeah, Warren has machines, but at my shop I've got Mach 3 running on a conversion of a Grizzly.
Okay.
U7.
Yeah, so we can use like a generic 4-axis machine tool model and represent it for simulation. So like you noticed here, I had to put the 0 to the center, and then I actually put the what is called the center of rotation to 0, 0. So we might be able to change it to the top, but this is just to show you how to run the machine tool simulation.
Yeah.
Right. I don't have 4th axis on the Miltronics, so we're doing everything in Mach 3 just to figure out the software part right now.
Okay, makes sense.
That's exactly what it looked like. See, there's no Y movement.
Yeah.
It's all X and A. This is A axis.
A and Z. That's right.
That's awesome.
Well, and Z axis, yeah, for the cutter.
X and Z, yep, stepping down in levels, and then it's just X and A. Do you have any questions so far, Warren?
No.
Okay, perfect. Okay, so
This is what we need to see right here.
okay, now let's go ahead and take a look at the second file that you had, right? And see how we could program it. Now, if we use the other one, we had the tube in there, right? So if I go back and grab this tube in here, and if I replaced it with a a cylinder stock as opposed to this one, like a tube stock, using a tube stock, then your simulation would be slightly, it would show what the tube would look like.
Okay, yeah.
So that would be available to you in the Pro, where I can select this and define a stock from selection. So now when you go into your simulation and you hit the play button, you'll notice that it represents a tube, and you can see the cutting in action as you get down to the depth. It shows it's being hollowed out right there.
Okay, I see the difference there.
Yep. So the Pro offers more options for defining your stock material.
Okay.
Okay, so I'm going to hit pause in here, and I'll also toggle off the machine tool visibility. Now let's go ahead and take a look at the second one. So I'm going to save off this part as well. Any questions before we take a look at the next file?
No.
Nope.
All right, perfect. I'm going to go ahead and load the other part. So I do see that you have on this particular part, I would say, a lot of artwork on it that you want to basically program it on a 4-axis or a rotary axis, so you get all of those features like sculpted artwork onto it.
Right.
Okay. So again, this part is in millimeter units, as you notice it right here.
Yeah.
So let's go ahead and take a look at it here. The workflow would be very similar to what we did. So you can either manually move that to the center if you'd like to. I can do a select all. I could say move. I can use the move command in Rhino, and then I can use the center snap right to the center of this part right here.
Mm-hmm.
I can put that to 0. There's your, or you can put it to the top, top face of the part as well.
Okay.
Now here we don't need these curves in here. I'm just going to hide that layer right there, if that would be okay with you.
That's fine, yeah.
Okay. Now I see that there are some hollow cross sections on the part on the inside. So are you going to be working off with the tube stock again for this as well?
Sorry, what was that?
Are you going to be using a stock that is hollowed out like a tube for this part?
Yeah.
Okay.
Yeah.
All right. So I'm going to just basically, what I'm going to do is put in a cylinder, like a surface, like a catch plane, so that the toolpad doesn't go past a certain area in here. So I'm going to use a circle command in Rhino, and maybe I'll just go in a circle, so that's how far you want the cutter to go into.
Okay, that makes sense.
Makes sense? So I can put in a radius in here. I could say maybe 20 millimeter radius or maybe 22 millimeter. I can use a value in here. If I say radius, diameter will be 43 millimeters. So basically puts and throws in a circle right there.
Mm-hmm.
And I can select this and do a surface. I can extrude it. Surface, extrude curve, straight, and I can go all the way up to this edge right there. So what I did was I just put in a catch plane or a catch surface on the inside so that the cutter doesn't go too far into it.
Gotcha.
Okay. The workflow is very similar. You define your machine tool. It's going to be 4-axis. And then you specify your stock. If you're going with the expert configuration, we could define it as a cylinder, and I can specify the radius. I could say my stock is going to be, radius will be maybe 28 or 30 millimeter radius. I could specify the radius of the stock. Do you know what stock radius is going to be, or diameter, offhand?
I was thinking of using a 2-inch tube. I know I'm going between metric and inch here, but...
okay, so if it's going to be 2 inches, that would be 25.4.
Let's say 50 millimeter.
50 millimeter would be the radius. Now it looks like there are some features that are, you may need a slightly larger blank because these features are sticking out here.
Okay.
Oh, yeah. Okay.
Yeah. So can we
I'll
just
probably go with a 28 millimeter or maybe a 30 millimeter for the purpose of demonstration in here. I can say 30.
Mm-hmm.
And I can zero these out. And the length is set to 150 millimeter. We can go with that. So there's your stock blank as you notice it.
Mm-hmm.
Yeah, now it's above the highest surface.
Mm-hmm. Highest point on the surface.
Okay.
So there's a couple of ways that we could program it. We could do roughing using 3-axis, where we rough it from the top, we index it, we rough it from the bottom. We could do that. Or we could do like a finishing in levels, where you can do multiple levels of the finishing toolpath as well. So I'm going to show you both the methods in here, how we can program this feature. So if you want to program this as a roughing using a 3-axis, and then you do instance it for like different orientations like 0, 90, 180, 270, you can do that. Index machining, where you lock the rotary table to different orientations. So for that, we could go to 3-axis. Now the difference between expert and pro is in the expert you get 5 different types of 3-axis methods. You get horizontal roughing, parallel finishing, horizontal finishing, radial and spiral machining. That's part of the 3-axis. It can also be used as index 4-axis. And in the pro configuration, you have all of the 3-axis methods, like advanced methods like re-roughing, plunge re-roughing. You get 3 illustration, remachining, offset pocketing, offset profiling, curve-based machining methods as well. So
Okay.
typically you'd want to do like a roughing process, start out with the roughing process. You grab a tool for it. So let's say you want to go with a 1/4 inch end mill for roughing process. You pick a 1/4 inch end mill. You set your feet and speeds. You set your clearances in here. You go into your cutting parameters. You can specify the tolerances for roughing. You can specify the stock to leave after it's being roughed. You could say you want to leave 1/2 millimeter stock. You could choose the cut pattern. You could go linear, which is like a lace cut pattern. And you can specify a step over distance, or you could even do offset or any of these cut patterns for roughing. And in the cut levels, you can specify how fine you want the cutter to step in the Z. I could do 20% since you're cutting steel. And you could set it to not go below a certain Z. So for example here, I'm going to say I only want to go to the mid-plane. So I put in 0, or I could even go maybe past 0 by 1/4 of a millimeter. And I set my engage and retract parameters, any additional cut parameters, and then pick generate. So in this process, it's going to analyze your part, it's going to analyze the stock, and compute the roughing toolpaths. So this is a 3-axis roughing, so you have all 3 linear axes moving at the same time, and your rotary table stays at the 0 degree position. So initially the A is at 0 degrees, or it could be, whatever you're calling it for your rotational axis. So that's roughing in levels. Now when I hit simulate, you'll notice that it's doing a roughing operation, or also known as Z-level roughing, or roughing in levels. So this is removing the excessive stock. Now I could be even selecting boundaries to contain the toolpath. Now your stock plan could be much longer, so that you have enough room to hold it on both ends of the chuck and the tail stock as well.
This is the fast way to get rid of all the excess.
A very efficient way to rough it out, because it takes into account your stock and then the part, and you can see that you're roughing it down in levels. So once you have it roughed down from the top, I could program a table rotate operation using rotate table setup, and I'm going to specify the angle. I could use any increments. In here, I could do just a 180. So I want to rough it from the top, then from the bottom. So you'll now notice that your Z-axis is inverted from the initial setup, rotated 180. And I can repeat the same operations. I'm going to make a copy of this, right-click copy, and then paste it. Right-click and paste. So the operation is now pasted in here. Now the operation is flagged as dirty, because the toolpath has to be regenerated, since there's a change in orientation and the features could be different.
Oh, okay.
So right-click and regenerate. So I'm taking advantage of all the settings I had from the initial operation. It's computing the toolpath. And the roughing toolpath has just been computed. We can run a verification. So on your machine, the part would have rotated or flipped over by 180 degrees. So RhinoCAM will compute and output the rotation angles. I'm going to pause and pick simulate to end. So it's been roughed from the 2 sides. And you can see it's a 3D roughing tool. But any questions so far?
No. For the finishing part, we want to use the decarb tool.
Okay.
Like maybe
So
60 or 90 degrees.
okay. So here's what I'm going to do. Rotate it back to 0. And perform like a pre-finishing operation first, with maybe a ball mill, and then go back and use a V-carve V-bit tool to finish it up. So we could do a 4-axis parallel finishing, and grab a tool. This could be like an 1/8-inch ball mill to do like a pre-finishing to remove, any excessive stock that's being left. Set the feeds and speeds. You can set the clearance. You can set the cutting parameters. You can see you can establish a low and the high values. And if I want to go along the axis of cut, and I can specify the total cut distance or length of travel in here. I want to go from 0 all the way to this end. And I can specify the step over. I could do maybe like 15%. That should be good enough for pre-finishing. And if I want to leave any stock in here, I can specify that value. And now I'm going to... I'm sorry, can you say that again?
Let's just leave that at 0.
Okay, we'll leave that at 0. Yep. So 0 means it'll finish it to the part surface. So what I'm programming is a long axis cut in here using a 4-axis parallel finishing. So the tool will traverse along the length of the workpiece, and then it'll rotate in step increments based on the step over that you put in. So by the time it makes one full rotation, you would have pre-finished or finished the part. So it's processing the 4-axis parallel finishing toolpath. Now this could work as your pre-finishing, or it could be a finishing pass. And it'll automatically identify all of these features. So you can see that the part in here has several complex features on the model. And how have you been programming these so far?
What's that?
How have you been machining these so far?
Oh, I haven't.
You haven't? Okay. Okay, there you go. The toolpath is now ready. That's your 4-axis toolpath. And by putting this, ID surface, you'll notice that the cutter will not cut past that surface.
Mm-hmm.
So let's go ahead and simulate this toolpath in here.
Wow.
Play button. So the part would rotate.
Mm-hmm.
And there's your pre-finishing. You can see all of the features on the part start showing up.
Right.
So I would pause it, and then I can pick simulate it to end, and that would run through the simulation, so you would be able to see the final result. So this is after the pre-finishing steps, and that looks pretty nice.
All that's left is the very fine details.